patient. What's your prognosis? 1,000 years, 2,000 years?
A person has already been born who will die due to catastrophic failure of the planet.
What did he just say?
Okay, can you expand on that?
Sure. The last time there was this much CO2 in the air, the oceans were 80 feet higher than they are now. Two things you should know. Half the world's population lives within 120 miles of an ocean.
And the other?
Humans can't breathe underwater.
You're saying the situation's dire.
Not exactly. Your house is burning to the ground, the situation's dire. Your house has already burned to the ground. Situation's over.
So what can we do to reverse this?
Well, there's a lot we could do.
Good.
If it were 20 years ago or even 10 years ago, but now, no.
Can you make an analogy that might help us understand?
Sure. It's as if you're sitting in your car, in your garage, with the engine running and the door closed, and you've slipped into unconsciousness, and that's it.
What if someone comes and opens the door?
You're already dead.
What if the person got there in time?
You'd be saved.
Okay, so now what's the CO2 equivalent of the getting there on time?
Shutting off the car 20 years ago.
You sound like you're saying it's hopeless.
Yeah.
Is that the administration's position or yours?
There isn't a position on this any more than there's a position on the temperature at which water boils.
The administration, let me try to, your administration.
And don't forget,
It
I need you to
supports wind and
stretch
solar,
40.
clean coal, nuclear power, raising fuel economy standards, and building a more efficient electrical grid.
Yes.
And?
That would have been great.
Let's see if we can't find a better spin. People are starting their weekends. The report says we can release 565 more gigatons of CO2 without the effects being
It
calamitous.
says we can only release 565 gigatons.
So what if we only release 564?
Well, then we would have a reasonable shot at some form of dystopian post-apocalyptic life. But the carbon dioxide in the oil that we've already leased is 2,795 gigatons. So,
What would all this look like?
well, mass migrations, food and water shortages, spread of deadly disease, endless wildfires, way too many to keep under control. Storms that have the power to level cities, blacken out the sky, and create permanent darkness.
Are you going to get in trouble for saying this publicly?
Who cares?
Mr. Westbrook, we want to inform people, but we don't want to alarm them. Can you give us a reason to be optimistic?
Well, that's the thing, Will. Americans are optimistic by nature. And if we face this problem head on, if we listen to our best scientists and act decisively and passionately, I still don't see any way we can survive.
Okay, Richard Westbrook, Deputy Assistant Administrator of the EP.
All right. You can realize that, huh? Thank you, by the way. Yeah, so this is where I've seen a lot of you debate about climate change. Most of the debates I've seen revolve around the three words climate change, inevitable, and that's sort of the development of the debate and where it stops. There's a lot of things I like about the way he presents the climate change narrative and a lot of things I dislike. So he does a great job of vividly describing storms that will create permanent darkness and level out cities, too many wildfires to possibly contain, massive food shortages and water shortages. Those are all good, vivid descriptions of what climate change is. But the bad part that I see a lot of you fall into the trap of is describing it in such apocalyptic terms and it's presenting such a unavoidable sort of picture of it that you demotivate a judge's ability and willingness to act, right? So there's a part of that video where he is like, doesn't your administration propose fuel economy standards and nuclear power and renewables? Like, yeah, for sure. What's the point of building any of that if it doesn't matter, right? And this is the problem with how I see a lot of climate change debates develop, is that you're not specific enough about why certain technologies or why avoiding a certain increase in warming is important. But rather you're just emissions increase 2 degrees, that's bad. It's okay, great, that's where we stop. How many of you have read an impact that is not emissions-based about the climate? Feel free, on this topic, yeah, what did you read?
Pollution.
Pollution?
First, a lot of people read the biomass stuff, kills 3.5 million people a year.
Yeah,
Indoor air
that's a
pollution.
great one. Indoor pollution kills a bunch of people every year. What else? How many of you said emissions? Feel free to raise your hands, don't be embarrassed, it's important. Yeah, a lot, I see like the, kind of. Alright, so we have indoor pollution kills people. Is that the most specific we've gotten with this topic? Yeah? Yeah? Alright, that's why we're having this lecture today, great. So, one of the hardest parts about debating climate change is that it is so broad and produces so many different types of impact scenarios and issues with the environment that it's hard and difficult to select one. What are some of the implications of climate change for other types of impacts? Feel free to list them off. Come on, it's not that hard. Yeah.
Like, are we talking like natural disasters?
Natural disasters are one. What else? Yeah.
Decreasing crop yields.
Crop yields, food shortages. Yep. Yeah.
Sea level rise.
Sea level rise. Come on. That's it? Those three? Droughts? Yeah.
Deadly disease.
Deadly disease. What else? Environment specific. Resource wars. Bunch of wars.
Biodiversity loss.
Biodiversity loss. That's it? We're good? Stopping there? Alright. We covered like 15%, 10 to 15%. The 2-degree threshold, acid rain, air pollution, biodiversity loss, deforestation, disease spread, economic crisis, endocrine disruption, eutrophication, methane release, the Montreal Protocol, natural disasters, ocean acidification, overfishing, ozone depletion, Paris goals, reef death, resource shortages, refugee crises, sea level rise, soil erosion, terrorism, water security, war. There are so many different types of impacts to climate change that it is difficult to select the most specific one to your impact scenario and explain why it matters specifically. So first things first, what are some of these that you don't really understand what they are or you have questions about?
How does terrorism grow?
Terrorism often occurs in places, mostly, right, the Middle East, definitely global, but mostly the Middle East, which has a lot of problems with overheating. It will be a region that is drastically affected by crop yields and water shortages. Terrorist organizations offer economic resources and infrastructure to access those. There will also be a really unpredictable and probably violent response from terrorists when they start running out of resources. Who will they attack to get those? It produces a bunch of regional instability, etc. And the terrorism impact is because terrorism is a big sort of scary word to a lot of judges, but it's sort of an impact scenario that will occur in a bunch of places. Like there will be mass political instability and crisis internally within countries all over the world when we start running out of water, right? What do you do then? Yeah.
Eutrophication.
Eutrophication is about the sort of carbonization and presence of toxins in water. So what happens when there's too much carbon dioxide in water and how that affects ocean and freshwater biodiversity. It's like a specific, like water-specific biodiversity loss scenario. What else? Yeah.
Endocrine disruption.
Somebody that's taken AP Bio, what's the endocrine system? Yeah.
It's like hormones.
Yeah, hormonal regulation. Turns out hormones and a healthy regulation of them are super important for reproduction, not just for humans, but for all wildlife. So when we put a bunch of toxins in the environment and pollute water sources and food sources for wildlife, it turns out that a lot of them have difficulties over time with reproduction. So we are making it harder for mostly fish specifically to reproduce, which is producing a bunch of sort of food shortages and destroying a lot of sort of ecosystems. What else? We get,
What's Montreal Protocol?
oh yeah, sorry, the screen's not all the way down. Montreal Protocol is about chlorofluorocarbons and hydrochlorofluorocarbons. So CFCs and HFCs. A lot of you have probably heard like about the bans on things like hairspray in a bottle because it creates holes in the ozone layer. We realized this was a crisis 30 years ago or so, maybe a little before or after that. We had an international proposal similar to the Paris Climate Accords called the Montreal Protocol to the United Nations that banned certain types of CFCs and HFCs used in refrigerants and air conditioning that were putting a bunch of holes in the ozone layer. Turns out we need the ozone layer. So there was a thing called the Kigali Amendment that worked to regulate that. But yeah, there's a bunch of CFC and HFC impacts. Anything else? We all good on the rest of them? But like I said, there's a million different types of impact scenarios and a bunch to learn about that you can talk about. But the number one lesson to take away from this is that there are so many impacts that you should be able to make yours specific. Okay? Not just 2 degrees, we're dead. That's it, emissions. It's over. This many people die from climate change, right? If you're talking, what are some of the climate-related scenarios on this topic? Okay, 2 weeks. Coal expansion. Why is coal expansion bad? It's not just because it increases emissions 2-degree threshold. Coal produces tons of localized air pollution, groundwater pollution. The workers that work for coal plants and mine for coal often face abusive conditions that will give them things like black lung and sort of lung cancer that will cause them to die. There are tons and tons of deaths related to coal plants that are not just based off of some vague emission scenario, but rather a very specific application of why coal plants are bad. Why is it important to make your impact specific? Anybody? Yeah.
Because if it's not specific, then it's just some vague, like, impact scenario that you can't really weigh very well.
Yeah, weighing. The more important, there's a really important reason that I've just sort of ranted about a bunch. If you're like, coal increases emissions 2 degrees, somebody can stand out there and say, there are 150,000 other things that increase emissions that will also get us to 2 degrees. That impact that you have described is inevitable and non-unique. What do you do then? It's good to have a specific impact because you can't just get non-unique. If you're like, China will go from 240 coal plants to 1,600. Every coal plant has a relationship with this much increase in lung cancer. The coal production kills this many workers, or groundwater pollution threatens water sources in all of these new areas. Are things that can't just be like, that's non-unique. That's already gonna happen, because it's not, right? But if you're vaguely like, emissions increases are bad, it will do a bunch of bad things. All of those are obviously non-unique. There's a million other things that will produce those emissions, right? It's super, super important to be specific. 2 degrees. I've heard almost, I haven't judged all of you, but in so many rounds at the tournament and in practice rounds, I've heard the term 2 degrees of warming. Why does 2-degree warming matter? Anybody? Somebody? How many of you have read the 2-degree scenario? Okay, so why does 2 degrees matter? I'm not gonna pick on, I'm kind of picking on you, but we'll get to it in a second.
We talked about like catastrophic events that happen when we reach 2 degrees.
What catastrophic events?
Like sea level rise and like decreasing property.
How much? Why does 2 degrees matter for that? It's like 78 degrees outside now. Why does it matter if it's 80 degrees? This is what parents think. Well, one, it's Celsius, not Fahrenheit. Very big difference. But yeah, can anybody explain to me why 2 degrees matters? Or take a stab at it?
Polar caps.
Polar caps? What does that mean?
I'm taking a stab at it.
Okay.
Ice caps are gonna melt.
Ice caps are gonna melt. Yeah.
Reversibility, like once you pass it, you can't go back.
Why?
Because once the ice caps melt, you can't go back.
Partially, but aren't they already kind of melting? How much more are they gonna melt? Why does that difference matter? Yeah.
Is it because like the carbon feedback loop, like
Positive feedback loops. Yeah, sure. So there's this important thing called permafrost, which we'll talk about in a second, which are the ice cap things you're describing. Permafrost in the Arctic is like really thick ice sheets, and when they melt, they release methane that has been stored in them. So they'll melt, release more methane, which causes more melting, which causes more methane release, which causes more melting, which causes, it's a positive feedback loop. There's a bunch of different ways this feedback loop happens across different climatic scenarios that we don't really have time to get into. But basically, if we hit a 2-degree threshold, climate change will continue accelerating because the rate at which we will melt those permafrost sheets and destroy other parts of the environment will accelerate because it just feeds off of it. So, but we'll also talk about that here in a second. Biodiversity, what's that?
Living things in the water.
Living things, yeah, like things that are not human How many species are there? Why are they important? Save the bees. Somebody tell me why we need to save the bees, please.
Food, ecosystem.
Food, exactly. If we're drastically losing bees all over the planet because of things like pesticide usage and climate change, a bunch of different scenarios. Bees are necessary to pollinate like plants and continue crop growth, which means that we're going to run out of food if we run out of bees. You might have seen that Black Mirror episode where there's a bunch of like robot bees. It's a decent episode. It's not my favorite. Either way, there's a bunch of reasons biodiversity loss is important, but biodiversity loss is not just globally the same. It depends on the regions. Is it like ocean biodiversity? Is it tropical? Is it desert-based? Is it an Arctic scenario? Like, there's a bunch of different ways biodiversity loss can be made specific and important. Okay, you should always, 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 always have a specific climate change impact, one that is tailored to your scenario and is an impact based off of the specific thing that you're doing. I would advocate that you should also have a generic climate change impact. So, let me see. Where's my climate change thing? Climate change impact. So this climate change impact card says it'll cause biodiversity loss, be an existential predicament for thousands of years. It will create wars, make wars, extreme weather, food disruption, sea level rise, terrorist attacks, collapse of ecosystems, economic, political instability, all more likely. Could be the beginning of World War III. Why do you think I think it's important to read a card like this, or like a generic climate change impact card?
Because your opponents spend a lot of time on it.
Sure. What's one thing you have to do in every debate round to win?
You can link into all of it.
Yes, weighing. If they have an economic scenario, you have a card that you've read in your case that says increasing climate change is inevitably going to cause your impact. If they have a war scenario, increasing climate change makes this more likely because you put political pressure and resource shortages on countries, and that makes their leaders face more crises, so that your impact's inevitable. Climate change will cause not virtually every, but the vast majority of impacts that your opponents are going to read, especially on this topic, like economics or war or also climate change, weirdly. So it's like, there's a bunch of ways that your impact should relate with theirs, and I think it's super important to both have a specific tailored impact and a piece of evidence that says you will inevitably turn their impact, and if you don't solve for climate change, their impact is inevitable. So there's a risk that you prevent their impact as well, right? So weighing is always important, and if you have your impact turn their impact, it's always a good thing. All right, 2 degrees. We kind of took a stab and guessed at why it matters, but we'll go through some specifics. So this chart illustrates the difference between 1.5 degrees Celsius and 2 degrees Celsius. The amount of people in the world that will experience extreme heat is 2.5 times as many. The sea Arctic ice that melts in a drastic way will, instead of being every once in 100 years, is every 1 in 10 years. We will lose twice as many vertebrates, twice as many plants, 3 times as many insects. The sort of ecosystem destruction will be almost 2 times as bad. The permafrost we talk about, which releases methane and creates these positive feedback loops, will be 40% worse with this 0.5 degree difference. Crop yield, 2.5 times lower than what they would be with 1.5 degrees. Coral reefs will basically all be dead, 99% of them. And fisheries, we would lose twice as many fish globally as we would by just a 0.5 degree increase. How many, can you guess how many of these scenarios I've heard described and around? 0, 0, 0, 0. There's huge, huge, huge differences in slight degree variation, like seemingly slight, right? 0.5 degree does not seem like much. It wipes out like twice as much fish, right? It makes permafrost loss 40% worse, right? Those are huge. Like, just a 0.5 degree will kill twice as many insects, or twice as many plants and animals, and 3 times as many insects. That's a big, big, big difference. And that's the reason climate scientists are like 2 degrees, super worrying. Turns out we can't lose that much. Like, we cannot afford, so the way our food system's set up, the way our water infrastructure set up, the way we depend on biodiversity, like plants, insects, and animals right now, we can't afford to produce this drastic amount of changes and lose this many resources in such a short amount of time. So there's a bunch of reasons the 2-degree scenario matters that I, haven't really heard people talk about specifically. And I think it's important to be able to particularize it and explain why that 2-degree scenario is important. So now can somebody explain why it's important? Come on, we just tried without going over this. Now that we've gone over it, somebody should be able to tell me why 2 degrees matters.
Like a specific one.
Any reason. What, if you're in a debate round and you read a 2-degree scenario, why does it matter? You have like 20 seconds to extend this impact and rebuttal.
Okay, ready? Okay. Well, because the difference between like 1.5 and 2 degrees is bigger than you think for the reason that crop yields rely on a specific temperature, which means that when you increase temperatures by 0.5%, I have to find it. Which one is it?
Yeah, 2.5 times the
2.5 times as, or like many crop yields will die.
Yeah, that's a good. Turns out if we lose 2.5, like if we lose almost 10% of the world's food, that's kind of scary. There are a lot of people that are already impoverished and food scarce, right? There are millions of people. There's like 30 million people in America that are food insecure, right? Like, and we are the developed, richest country in the world. There's a bunch of people all over the globe that will run out of food and water with just this 2-degree increase, right? There's a ton of different ways that this matters that you can explain and that you should be able to particularize. I do not want to hear more debates during the intensive week that just say 2 degrees, emissions, kill us all, that's it. Yeah.
But aren't like none of these things are like specific to like I mean all of these things are non-unique pretty much. I mean you can make that argument.
Oh, we'll talk about that in a second. This is why I've said specific and general, right? Have an impact that cannot be non-unique, and then one that is arguably non-unique. Yeah.
Here's my thing. So like everyone talks about this 2-degree scenario. But, like, why is 2 degrees any worse than like 1.99 degrees? Like it's still scalar, right?
Okay, with 1.99 it's probably not.
Well, exactly, but like 1.9, like
It's
I don't-
because it's a nice whole round number that climate scientists can talk about when they discuss thresholds for
Sure, okay,
terrible
but I feel
warming.
like everyone in the debate world makes it out to be some kind of a bright line impact when it's
Correct.
not.
I think it's a bright line impact.
But like, why is 1.9?
You're right, if it's like
different too?
1.99, we probably trigger that bright line. But inherently, when you talk about climate change, you're talking about the global environment entirely, right? Like, it's really hard to describe a bright line for the global environment. Similarly, it's hard to describe a bright line for when does this recession happen? When does this war occur? Any large-scale impact, bright lines don't really exist, you just kind of imply that they do.
But like any degree, like any 0.1 degree in warming still triggers more of these impacts.
Yes.
So it's still more scalar than like
Correct.
war.
Yes, that is definitely true. So that's part of the explanation that we'll get to here in a second, when we cover accelerating climate change. But like, do you think there's a difference between 4 degrees in warming and 2 degrees in warming?
Obviously.
Obviously, why?
Well, like it's because these things are all going to get so much worse. But
Oh,
like,
but they're already gonna happen. This is the level of debating I here. Why does 2 degrees and 4 degrees matter? What's the difference?
I mean, I would assume 4 degrees means all of these like times 10 or something.
Sure. Yeah, all of these times 10. Non-unique times 10. All right, accelerating climate change. We'll talk about it here in a second. So, accelerating climate change. Why does it matter? This is kind of what I'm talking about. Why does, putting a ton more coal on the grid and China expanding it make a difference? Come on, somebody guess.
Makes the effects happen faster.
Yeah, it makes the effects happen faster, but why is that important? Huh? Makes them worse and faster. Why does that matter? Yeah.
Because if you prolong it, you might find a solution to it.
Yes, thank you. Because the longer we have to develop technological solutions to climate change or adapt to climate change, the less bad these impacts are. If we discover a way to reverse ocean acidification or make the climate cooler or implement a bunch of technologies that we're going to talk about here in a second, then we'll be good, all right, for the most part. We'll be a lot better. Or if we just figure out a way to like make cities more resilient, let's build some seawalls so that when sea level rises, New York isn't underwater, Miami and San Francisco aren't just entirely underwater. Let's build some sort of adaptive features that make that really unlikely. The more time we have, the less dramatic and impactful it is, because it's the more time we have to adapt to it or possibly mitigate it. We can come up with technological solutions, fingers crossed, to do anything about it. If you're an optimist, not a pessimist. So we're going to talk about two very important and distinct things within the climate change debate: mitigation and adaptation. What do you think mitigation is? Yeah.
Decrease emissions, like decrease the warming scenario.
Decrease emissions. Sure, but can't you do that in an adaptive way? I don't know. Anybody? All right, mitigation. Mitigation is doing something that will lessen the amount of emissions that are put out. So you're correct to say it's like about emissions, but it's about before you emit, how do you lessen them? Nuclear power, renewable energy, a bunch of different alternative fuels, just like cleaner coal or higher regulations on the type of oil you can produce, or LNG, which is liquefied natural gas, which is what you frack for, right? There are a bunch of regulations you can put, or different ways of producing that energy that would lessen the amount of emissions that you put out. It would mitigate the overall number. So when you talk about avoiding a 2-degree warming scenario, you're talking about a mitigation strategy, right? You want to mitigate emissions enough to where that doesn't occur, which is theoretically possible. You know, I'm not as pessimistic as Toby. It would definitely require like a drastic shift in the way the world consumes energy very quickly. But it would theoretically still be possible to mitigate climate change past an existential crisis scenario right now. Because one of the things that annoys me is we talk about this 2-degree scenario and just sort of imply extinction, right? A lot of your climate debates revolve around the word extinction, without ever explaining how humanity goes extinct. Like, sure, the world will get hotter, we'll run out of parts of food and water, we'll run out, like, there will be biodiversity loss. Why does that mean we all die off as a species? Anybody? How long would it take? Thousands, tens of thousands of years, thousands of years, hundreds of thousands of years? Who knows, right? Like, we just kind of imply that climate change is this extinction level event for humanity, without ever explaining why it might be or why that specifically would occur. And that kind of really annoys me and your other judges, because you just kind of rely on this word extinction. You're like, 2 degrees equals runaway warming equals extinction, we're done, we have to solve for it. Thank you, good night. That's not really a great way to debate, and it doesn't explain a lot of the internal links, right? Climate change is not just this thing that's gonna immediately cause extinction, or even in the short term cause extinction. It's something that we have a ton of time to adapt to, but the worse and worse we make it, the worse all of these specific impacts we've talked about get. Adaptation. If mitigation is stopping emissions before they occur, what's adaptation? Rylan, what's adaptation?
Like adapting to the effects, like to the bad effects.
Yeah.
Making them less bad.
Yeah. So if the emissions have already happened and the environment is now polluted, and we have a lot of increased CO2 and carbon, how do we adapt to it? I've only judged one debate, shout out to Zoe, where there was a really good adaptation scenario. You're just like, one is locked in, it's terrible, it's gonna kill a bunch of people, sure, but we need to make the infrastructure in developing countries more resilient and able to respond to that warming, right? Turns out, if you have like concrete roads and sort of infrastructure that's developed, you can respond to flooding better than if your road infrastructure and transportation infrastructure is like dirt, right? Like, you can have your whole road system wiped out for days or weeks or months on end from a typhoon, and that just destroys your economy and development, right? There's a bunch of reasons why infrastructure is super important, and how we respond to things is important, right? Look at the difference between a flooding impact in Puerto Rico and a flooding impact in Houston. Obviously, the way our administration allocated resources for alleviation was different, but one had their power grid like 90-something% offline for months on end, and like just sort of just cyclical issues with recovering from warming, and the other kind of had some homes destroyed, had some major impacts to infrastructure, but just kind of bounced back. They didn't have the power grid go offline for a long time. They didn't have like tons of resource issues for a long time. Like the impacts were drastically different between Puerto Rico and Houston because the infrastructures that exist in both places are different. And like I said, obviously the amount of resources allocated to help relieve that had some level of difference, but the infrastructure development itself was also super important. So when we talk about this topic, which is developing infrastructure across the globe in largely developing countries and countries that do not have the best infrastructure, it's really important because climate change is going to make that infrastructure more important. So when there's flooding or typhoons or tsunamis or we've seen countries where hurricanes can wipe out like massive amounts of poorly constructed buildings. All of those things, maybe earthquakes, we'll see, are going to get more and more frequent because of climate change. They're going to get worse and worse, and unless we have the infrastructure in these countries to sort of respond and adapt to it, the amount of people that will die will drastically increase, and the amount of recovery time that it takes will do nothing but go up. So it's super important that we adapt. So mitigation, preventing emissions before they occur, adaptation is adapting to it after they occur. There's another really important aspect of adaptation that I want to talk about, and it's the reason people should stop saying climate change inevitable, extinction, blah, blah, blah. Because there is an absurd amount of super optimistic literature out there that says we are going to create some sort of technological solution to climate change. Has anybody heard of these wondrous technological solutions?
Carbon trap satellites.
Carbon trap satellites. Yeah,
really cool.
Carbon capture systems, broadly. It's like you take carbon out of the air in the Earth's environment, you like store it underground, or you store it in outer space. Yeah.
I remember hearing about like floating cities so they don't get flooded or something.
Yeah, like floating cities or infrastructure that prevents flooding. Seawalls we talked about, which is just literally build a big wall in the sea to keep the ocean out. Sounds ridiculous, but there's a reason the U.S. military is recommending construction right now for many seawalls. What else? What's some adaptation? How do we adapt to climate change? Has anybody ever heard of geoengineering? No? Nobody? And you? Yeah? No? Nobody? So geoengineering is science that will, technology or science that will literally alter the geology of the Earth. Have any of you seen Snowpiercer movie? No? Yeah, it's fine. It's kind of dark. But geoengineering is like trying to produce technological solutions to warming that would, things like putting chemicals in the air, or developing some sort of composition of chemicals that would lower temperatures, just like by putting them in the air. Mostly geoengineering is used to adapt to biodiversity loss. So if there are certain regions of the world that have like snow-capped mountains, and that's where a bunch of animals that are very specific to that region live, but now it's getting too hot and the snow caps are melting, scientists will try to like artificially put snow in those areas so the species can survive, right? Instead of just like transferring those species across the globe or whatever. They will geoengineer and change the literal geology and like physical environment of the world in specific parts to try to adapt to warming. Super dangerous because we could just like accelerate the destruction of certain parts of the environment. But let's just trust scientists. There's a bunch of evidence both ways either way. Alright, reversibility. I guess we kind of just talked about this. Is climate change reversible? Does anybody think climate change is reversible? You got one hand? Anybody else? Two hands?
I think like up to a certain point.
Up to a certain point?
Yeah.
Don't we have like,
Is it the 2-degree point?
I don't know.
Yeah.
I
Right.
don't.
I've heard it's like until like 2030.
2030?
That's what I've heard.
2 degrees? 2030?
But like, I think we're just kind of screwed anyway because we're not making any progress.
You know, science will find a way. Some people say.
Stop relying on science. Just make the change you want to see.
Yeah, but money.
How are you supposed to do that without science?
No, like
How are you supposed to
everybody
achieve?
should like focus on climate change.
But you need science to do that.
Yeah, so it's unclear if climate change is reversible. I would say most people don't think so, but there are definitely articles from qualified scientists that you can read in debate rounds that say, we'll adapt, we'll reverse it, we'll survive. We'll do things like geoengineering. We'll suck all of the carbon out of the environment. We'll put some sort of chemical in the air that'll make it all colder. We'll develop a way, so even if there's water shortages, we will desalinate the ocean's water, take all the salt out of it, make it drinkable, infinite water. We'll do a bunch of things like artificial crop sort of generation. So even if it's hot and we have crops destroyed, we'll have a bunch of indoor farming facilities that are fine. We have air conditioning, we have energy, we'll be good. We'll figure out a way to come up with more water and more food, and we'll just live. It's fine. That's more adaptation, but it's like, a lot of the things are reversible, like ocean acidification or the destruction of water. It's like, we'll find more water. You don't believe me?
Yeah, no, a video just started playing on my
Okay, fair. But yeah, no, the reversibility debates, it doesn't go that, it goes really in depth, but most people will say, no, it's not reversible. Some people will be like, sure, maybe. So, you know, you could read those sure, maybe cards, but there's a lot of evidence. Okay, defense. So we talked a lot about how to describe your climate change impact and sort of go through ways to make it specific, etc. But I'm really tired of the only defense to a climate argument just being like, it's inevitable. Other sources of emissions, it's inevitable. What are other defensive arguments you think you can make against climate change impacts? And sure, it does depend on the type of impact, but. Yeah.
Well, you can like do things by saying like it doesn't lead to extinction necessarily, or it's reversible.
Yeah, doesn't lead to extinction. I was just talking about how like this whole extinction narrative is silly. Sort of silly. You know, it might be true, it's probably true, but it will take literally tens of thousands of years. Like, we're just not gonna just die off. What else? Okay, let me just show you the amount of impact defense you can have in warming. So let's say, there's the generic. You have there's no environmental impacts, they're sort of all localized and gradual. The Earth doesn't just have one giant ecosystem, right? There's like deserts, forests, Arctic areas, rainforests, like tropical regions. These are all isolated. There's not like, if you have biodiversity loss in this area, it's everywhere. If you have, like, heat impacts affect desert areas very differently than they'll affect like northern Canada. There's a bunch of localized and specific types of impacts that it's important to sort of understand. Acid rain doesn't matter. Biodiversity loss is not that important. We've been doing a lot of things to adapt to it. Scientists and sort of wildlife restoration people have been protecting the extinction of species for a long time now. Like, we have a bunch of ways that we sort of try to preserve and work to protect certain ecosystems. They can definitely lessen the impact of that. Deforestation doesn't matter because it's been decreasing. It takes a ton of time to sort of have any impact at all. Also, people plant tons of trees. The amount of conservation organizations that are like, sure, we can cut a bunch down and we'll just plant a bunch more and we'll make up for it. We actually plant way more trees than we cut down at this point. It takes a long time for that to sort of happen. Why are trees important again? Yeah, they're a form of natural carbon capture and release, right? They take in carbon and release oxygen. Endocrine methane, ocean acidification, ocean biodiversity, overfishing. So there's like a bunch of evidence everywhere that's like, all of these things are super resilient. All of these things are recoverable. There's a million different ways that we could avoid a lot of impacts, like soil erosion is scientifically proven to not be that big of an issue. We can constantly diversify. We could just move to other areas. We could do a whole bunch of things, right? There are defensive arguments to every specific type of climate change, and you should be making specific defensive types of arguments. A lot of you have done a really good job of, instead of, you're like, I don't really know what defense to read, so I'm just gonna say X thing is worse. Biomass is worse than coal. You're like, I don't really know how to say coal's not that bad, so I'm just gonna be like, biomass is so much worse. Which is a fair strategy. Biomass is worse if it was used as widely. We didn't even talk about biomass. What's biomass again?
It's like wood,
Wood and what else?
like plants.
Animal waste. Plants. Yeah. A lot of people use it as solid cooking fuel. So if you don't have electricity, how are you going to cook food or light your house without lighting wood or plants on fire? That's how you cook. Turns out when you breathe in an enclosed environment that's filled with smoke from wood, it is bad for your lungs and you die. So millions of people die every year from indoor cooking and solid cooking fuels. Either way, there's a million different ways that you can answer climate change scenarios about the environment being resilient. We can adapt to it. It is reversible. There are technological solutions. There are conservation efforts. There are worse environmental factors than things like coal. There's so many different ways to answer this, and please, please, please start using them instead of just saying climate change inevitable. Climate change inevitable, those three words are not an argument. You have to read evidence on this question. It is a good argument if they read a generic emissions. If somebody gets up there and like, 2 degrees is the worst thing ever, coal causes 2 degrees. Obviously it's great to give up and answer it with that 2 degree increase is inevitable, we're already locked in. Very good answer, very compelling, very true. Not the only one you should make, and not the only one you should rely on.
By 2030.
Huh? Oh yeah. Status quo solves.
This card is what?
No, this card's great. It's this person has an MBA at Stanford and he's a lecturer in distribution and clean energy at Stanford. Mr. Tony Seba. The age of oil, gas, and coal will end because of tech. The industry is giving away. Clean disruption is inevitable when you consider exponential improvement of tech. By 2030. Sorry, that's a decent piece of evidence. But yeah, like I said, there's a bunch of evidence. It's like, this card's pretty good. It's like, global tipping points are improbable. They're gradual and smooth. Ecosystems are super different, not connected. Local circumstances control things like diversity and gradual change. We're not at some sort of planetary extinction boundary. There's no evidence that says this is an actual thing. It's just hyperbole. Either way, it's 10:30. If you have questions about climate change impacts or debating them, just let me know. I hope you've enjoyed it. I know it's a little bit of a depressing subject, but remember, we'll just adapt. That's fine.